In the last 3 weeks of February, we've shipped more code than almost all of September and October combined. So how did we increase our velocity so much? And how do we maintain quality? Hi everyone. So this is actually my first proper talk at an event like this, so bear with me if I trip over my words. The talk that I'm going to be giving today is just about how I've actually stopped handwriting code, and I'm actually not the only one either. So I stopped writing code by hand in about September of 2025. And it's not just me. Every single one of our engineers has actually completely restructured their core development workflows to be more AI native. And then as a result, our developer velocity has significantly increased. I'm going to go into some of these things. But before I start, just a quick show of hands. Who uses coding agents every single day in their core workflows, right? You open up your laptop, you have a coding agent there, and you're executing on tasks. Yeah, fantastic. Okay, good. Hopefully you guys will get something out of this then. We have a lot of coding agents, right? There's a bunch of different types of coding agents. And I mentioned earlier that we've all restructured and become a lot more AI native. When someone says something like that to me, my first question is, what the heck does it mean to be AI native? And second, what were the outcomes, right? What actually happened? What were the results? And so I mentioned earlier that our developer velocity has increased significantly. So developer velocity is notoriously difficult to measure, right? But a simple definition that I think generally people can agree on is that we're asking how quickly can we reliably turn ideas into working software, right? How reliably can we do that? And so there are a few signals that we kind of now rely on to figure out whether those things happen. And it doesn't need to be perfect, but if you keep these things in mind and you use the same measures across a time span, you can get an idea that, hey, something is changing, something is improving, something might not be working as well. So one of them is deployment frequency. So how often do we ship changes to production? For us, this works with number of commits because we deploy on a continuous timeline. So we deploy every single day on almost every commit. What is our change failure rate, right? What percentage of those changes end up causing incidents and someone gets paged on call, and then that needs to be rolled back. And what are the lead times for our changes? So how long does it take for our PRs to go from being opened to being merged? And how long do our issues in our issue management system, in our case linear, how long do they stay in progress until they get moved to done? So again, they don't need to be perfect, but if you use the same measures across a period of time, you'll get an indication that something has changed or hasn't changed. So this is our commit graph over the last 6 months. That's our actual commit graph over the last 6 months. In the last 3 weeks of February, we've shipped more code than almost all of September and October combined. And that's while we've been doing that, our change failure rate has stayed pretty much consistent, and it's even decreased a little bit in February. Same with our lead times for our PRs. We're trending down, which means we're merging code a lot faster. And then the same thing with our linear issues, where they're staying in the in-progress state a lot less. Our headcount hasn't changed much in those last few weeks, right? And you'll notice also there's the P50s and the P95 times. There are some linear tickets that really mess up this, this data. So how did we increase our velocity so much? And how do we maintain quality, right? The change failure rate is a good measure of, as we increase our velocity, does our quality decrease or get messed up? So let me introduce you to some tools, just to give you a bit of an overview on what I'm using every single day, and I'll take you through a workflow that essentially works for me. So you've got your main coding agents, you have Claude, Codex. You have this interesting tool in the middle here called Conductor. How many people have heard of Conductor? Oh, okay, interesting, cool. We have Cursor, which also actually is a coding agent, but is also an IDE. And then anything you can use to use a terminal. I use Warp in this case, doesn't really matter. I'll go through how these play into the workflow a little bit more later. So let's talk about the actual workflow that makes this AI native, right? As an engineer, when someone gives you a task or an issue or a problem, how do you usually start, right? You start with a plan, some way of gathering context, gathering information, and then you come up with an idea of a solution that you want to work on. So you then review that plan, right? You might give it to a colleague, you might give it to someone else, or you review it yourself to see if it makes sense, if it meets the requirements that you've met. And then you execute, right? You write your code, you will make the changes that you need to make, and then you review it again, right? You give it to someone else, you give it to one of your colleagues, you get someone to review those changes. And then you ship, and then you review. So there's a lot of reviewing that happens, and there's a lot of changes and plans and things that you're doing in between. So what's interesting about this new workflow or a new way of working is that these stages, the plan and the execute stages, are largely automated by coding agents. I, as the engineer, actually focus a lot more and a lot heavily on the review stages. And so what does that actually look like in practice, right? We've got any sort of coding agent opened up here. You have a prompt, you give it a prompt, but you're in the plan mode initially, right? So something that I really recommend for everyone is that if you're making big, complex changes, it's really, really beneficial to start in plan mode. You kind of want to work with your agent just as you were working with one of your colleagues, where you're spending time exploring the code base, discovering what needs to change and why. So you give the agent a clear and concise prompt, and you treat the agent's response like a mini design doc that you would review just as you would any other design doc that you received from your team. Right? You need to review the plan that ends up. You look at the structure. Does it make sense? Will it meet your requirements? All that sort of stuff. So this is the best part about the planning stage, that you can go back and forth with the agent. And another really important thing is it's a great time to intervene early, right? Think about plans that you create as tech designs, and then you implement them, and then someone's like, hey, why did we plan it this way? We should have just done something differently. And now you have to change your entire implementation. It's the same principle here. Nothing really changes. So the next thing is you execute. But the tip here is that you execute with a fresh context window. And so why does this actually help? Why? What benefit does this provide here, right? Your context window is really important, because if you start loading things up with things that you don't need, the agent finds it more difficult to figure out what's actually relevant, right? Your agent is focused on what it needs to do, but if it has a bunch of information that's irrelevant, it's going to be much more likely to make mistakes. But this is where usually most people will find the issues with coding agents, right? They're going to write broken code. They're going to get stuck. They don't really know how to fix the issues that they face. And so this is where I want to introduce probably the most important concept of this talk, and that's feedback loops. So if the workflow is like the skeleton, the feedback loops are like the nervous system. They give you a way, or they give the agent a way to actually react to things that are happening. Feedback loops give your agent a way to verify their own work. And the better your feedback loops, the more likely it is for your agent to actually give you a working output that meets your requirements. Some examples of feedback loops that you probably already have in your repositories, by the way. Running tests through the CLI, type checking, linting, formatting. A new one that looks a bit new but actually already exists and has existed for a while, but that's browser access. So you have your end-to-end tests that you'll run sometimes through the CLI, but this is just another interface for your agent to be able to then access the browser and get information and context on what's happening. You have your system logs, so information that might exist somewhere in like some log file, in a Docker container, somewhere that you can read through and you read through yourself, but you might want to give the agent a way to read through those log files as well. And then you have, again, a relatively new concept, but MCP servers that essentially allow your agent to communicate with external systems in a more structured way. So how does your agent actually know that those feedback loops are available? So I'm sure everyone that works with agents have an idea that you have these things called like agent.md files, Claude.md files, things like that, right? They're files that are always added to your conversations with your agents. So you might have a Claude.md file or an agents.md file. At the start of every single new thread that you have with your agent, all the information in that file gets added into your thread. And so the agent always knows that the things in that file exist and are there and can refer back to them. So you don't have to retell it over and over again. And so this is one of those situations where your feedback loops, what feedback loops are available, how do you invoke them, and then when do you invoke them, That's really important stuff to put in your agents.md file. So your agent can go back and refer to those things when you need to. Here's like a snippet of our agents.md file. I'm not sure if that's readable everywhere, but it's really, really straightforward. We just tell it that, hey, you can run install using bun install. You can run test using bun test. You can run lint. You can run a specific test file using bun test and then the path to the test file. So it's things like this, and that can get a little bit more complicated. And if you set this up properly, by the way, you'll notice that at the end of your agent's work, you'll see a bunch of linting steps, testing steps, and ways to verify that the code that's been produced actually works and actually runs at the minimum. And so what's interesting here is that this works great for simple workflows, things that are almost kind of like self-documented, or things that might be a little bit more complicated that isn't already documented in your code. But if you start adding complex workflows to this file, you'll notice that things will start getting ignored, right? Parts of your agents.md file will not always be relevant at all times. And so the more complexity you add to this, the less important each individual unit of information becomes. And so this is where I'm introducing, I guess, the next concept that I want to talk about, which is agent skills. I'm sure who's used or heard of agent skills so far in this room? Okay, awesome. So some people have. So I'll give you a rundown on what agent skills are. So if normal documentation, markdown files that you have in your code base explain what something is, an agent skill is a way to explain how to do something step by step for the agent. So you can think of them as procedural guides that give your agent new capabilities. And so one interesting thing that is unlocked with agent skills is that you also give the agent information on when to invoke that skill, right? You don't just tell it what to do, you also tell it when it's applicable. And the agent can then figure out when you're doing something naturally that, hey, this skill is applicable to what we're doing right now. I'm going to grab the context from that skill. So it's lazy loaded information in your agent context. Some examples of interesting skills that we have, you can see these on the Tesla registry. You have like a systematic debugging skill that teaches your agent how to actually approach a bug step by step. You might be facing a bug that's specific to your infra, right? And debugging that might not be very obvious. So you might give the agent a step-by-step workflow on which APIs you need to call to figure out if there's a problem in a specific space. Another one is building an MCP server. You might have a bunch of small services that you might want to start repeatedly updating to have an MCP server for. You can package that up into a step-by-step workflow that now the agent can use to then extract each of those new services into its own MCP server. So instead of the agent improvising every single time, or you having to give it information or the same prompt every single time, you can just give it this repeatable playbook that makes the behavior much more reliable, and it's also a feedback loop that you can control. So there are two skills that I use in almost every single workflow that I do every day. That's a code review skill and a code simplify skill. So I'll quickly skim through these, but the code review skill is essentially I run it at the end of every single coding thread that I have, right? I work with the agent, I do a bunch of work, I review the changes, and then I run the review skill, again, in a fresh context window. And it will run a review on your code just like it would with any other engineers that you have, where it'll try to identify issues with your style, it'll identify architectural concerns, it might identify some bugs or some code smells that you've added, and it'll produce a report that you can then figure out how you want to action. Right? It's not going to action it for you. It's just creating a report, and then you can decide whether, hey, this part of it makes sense, this part doesn't. Like, I'm going to figure out whether I want to action this or not. Another one that has been incredibly useful for me has been the code simplify skill, right? So agents often produce a lot of code, and that code isn't always very useful, right? The code might be too bloated. It might have unnecessarily duplication. It might have more ways of doing something than actually needs to be done. And it also might have recreated concepts that already exist in your code base. So the code simplify skill is a great way of preserving behavior, but trying to simplify and lessen the number of lines of code that you've added. Because remember, every line of code that you add to your code base is a liability, right? It's something that you're going to need to maintain. It's something that you're going to need to test and make sure that either you or your coding agent have context over in the future. And so if you do this, you'll get some output, and it says that, hey, like I've been able to simplify a bunch of things that you did in your branch, right? I can clean up a lot of this stuff. So I think most of this stuff that I've kind of outlined here, I think some people have an idea on, or is pretty intuitive. But it's the next part that gets really, really interesting, because we have this workflow, but it doesn't feel very fast, right? It doesn't really explain how we went from shipping like, a few hundred commits a month to 300 in a week, right? So this is where the idea of parallelization comes in. So right now, our workflow is pretty serial, right? We plan, we wait for the agent, we review, we wait for the agent, we PR review, we wait for the agent, and then we deploy, right? So there's a lot of waiting between steps. And that's the new bottleneck now. If you can figure out that initial workflow, then parallelizing it becomes really, really powerful. But what does that actually look like? So let me introduce you to Conductor. Conductor uses Git work trees to parallelize your coding agents. And so for me, I didn't actually know what work trees were until earlier last year. A work tree is just another checkout of the same repo, sharing the same history on the same machine. So it essentially means that you can create multiple branches and work on those branches in parallel on the same machine. And so something that's really powerful about this is that think of it as you Git cloning your repository again for every feature that you work on, for every branch. But instead of having to do that yourself every single time, Worktrees gives you a native way of doing it. Git already has it built in for you. So now you can have agent A that's working on a plan on the first workflow, and while you're waiting for it to finish its plan, you can kick off a plan for agent B. And while it's working on its plan and doing its own research, you can kick off a plan for agent C, right? And what your work looks like now is that you're moving between each agent, reviewing the plans, reviewing the diffs, the changes, and then running your simplify, your review, or giving it more direction on what it needs to do, right? If you condense all of this, you're spending a lot less time waiting for things to happen. And you're spending a lot more time actually just directing the different agents in your team on what they need to do. So what does that look like in Conductor, for example, right? I can just hit new workspace. It does all of this for you. It handles a lot of the underlying logic for you. It'll create a new workspace, and then Conductor will go then make a clone of your repository, and then it'll attach a coding agent to that clone. You end up with multiple work trees, and they all have their own changes, their own in progress. I've created a PR for that first one, so that one's in review. So you can get a good overview of what's going on for all the changes that you're working on. And so something that comes up here now is that you've got 3 or 4 different changes or issues that you're working on. But you need to make sure that you're still verifying them yourself, right? You need to go to each branch. You need to make sure that things are working as expected. And so if every time you clone a repo and you have to do a bunch of steps to set up your app, this falls apart anyways. This doesn't really feel like magic. It doesn't feel like much because you still have to now copy a bunch of things over. And so you're going to get slowed down. So we need a way to quickly start your app and verify your changes. So some changes that you can make is having a single script that essentially runs everything for you and just checking that into your repository. Nothing needs to change. You just run a single script, and that script contains the things that you need to do to actually set up that repo and actually then run your product. So something interesting here is also a lot of what you'll notice is that for a running instance of your product on your machine, you might have specific ports that are assigned to it. You might have specific configurations that are assigned to it. So you can kind of go 2 ways. You can make it possible to have multiple instances of your app running on the same machine, or you can make it easy to start your app and then automatically close any other running instances of your app. It kind of depends, like whatever works best for your product. Like for example, if you're using Next.js or Vite or whatever it is, it can automatically reassign a new port for your web app, right? So you don't have to necessarily worry about closing the old one, although you probably want to clean up a bunch of those old ports that are running. So I've gone with number 2 in my case because it works better for our setup and our repo. And so for us, we simply have to install dependencies, copy over the environment variables, and then run our def script. Once we do all of this, you can add all of this to Conductor as well. So every time you hit that new workspace button, Conductor can automatically go and run a script for you that sets up the things that you need to do. Call it install, call the bun install, and I've got a little alias that just copies over my environment variables from just a folder and a file that exists already in my laptop. And then the other issue is that you might have existing processes running on ports already, right? You can have a really simple script. Just close all the ports, right? Find the ports that are relevant to you, kill them, and then restart your development environment. So all of these things now make it easier for you to switch between your workspaces, hit run, just a single command, and then have your app ready to review the changes that you've just made. Well, we can take parallelization one step further. And so I want to introduce the concept of cloud agents. So the mental model here is that if your local agents are for interactive hands-on work where you're like tight in the loop, your cloud agents are essentially for offloading background tasks and fire and forget jobs that can become something that you can review later on. And there's a bunch of different ways of doing this. And it really does depend on either A, the agent that you're using. So Claude Code has something that's natively built into it that uses web agents that you can configure. Or you might have to build it yourself, right? Depends on the agent, depends on what you're working on. But they let you run tasks asynchronously on some remote infrastructure somewhere else. You'll open up or spin up some container, it'll pull down your repository, and then it'll run Claude Code just as it was on your computer, make the changes, and then create a PR for you. So an example of something where this becomes really powerful is these can start integrating into your Slack or into your messaging systems and platforms and exactly into where you work, right? So it's powerful because, another example here is that someone pointed out a really small issue on our registry page where the skills were being filtered in some way. And so we had a discussion about it, we gathered some context, and then I'm like, hey, Claude, can you just look into this for me? There's no extra fancy stuff that's happened here. Claude will now go and pull down our mono repo, it'll make the changes, make the fixes, and then I can go and review the PR afterwards, right? I don't have to set up the environment locally. I don't have to do anything. Now I can go and review those code changes later on. So it's feedback loops, right? The only reason that works as well as it does is that when Claude goes and makes those changes, it has a way of not only linting the code, formatting it, and figuring out whether what it's done goes by what you need it to do, right? And so it's run the tests, it's run the other dependencies that it needs to run. So we fixed up that feedback loop. And so I know I've just kind of bolted a lot of information there at everyone. So I'll quickly spend a bit of time to summarize. I stopped doing the parts of engineering that agents can do better and faster than me. And so I can focus on the things that the agents can't do just yet. And at the moment, that's making decisions and directing the product under a set of constraints, right? That's all where we're working. We're working under a set of constraints, and we have to make the decisions because every decision we make ends up impacting the business as a whole and the direction of the business. And so it's important to not count that out. And at the moment, our coding agents don't have all the context they need to be able to do that stuff. And so you can offload some of the things that they can automate. This is what you do. So I introduced a bunch of concepts. There was plan mode, Git work trees, cloud agents, parallelization, feedback loops, agent skills, fresh context, a bunch of stuff. But you'll notice that these things you already are familiar with in isolation, right? These aren't new concepts as a whole. You already know that when you start a task, you spend a bit of time planning on how you want to figure it out. You know that you can parallelize some things that can be parallelized if they're not going to be overlapping each other. The feedback loops thing is really important, right? Have you ever worked in an environment where it takes you a few days to figure out whether what you've built is actually correct or not? You'll know how painful that is to move quickly, right? So this is stuff that we're already familiar with. And as a result, it actually applies really, really well to our coding agents as well. So what can you actually try in the next 24 to 48 hours that might help you see some of the improvements that we've made here at Tessel? So try the plan, review, and execute workflow. It's very easy. You already have your coding agents there for you. Go into plan mode, whip up a plan, make some changes, work on the implementation, and then execute it in a fresh context window, right? You can already do that with your existing coding agents. Number two, you'll notice some issues with that. Make your feedback loops accessible and put them in your agents.md file, right? And work on those feedback loops. The better your feedback loops, the more likely it is for your agent to actually produce good code. And I can't overstate that enough. everything that we've been doing recently has been improving our feedback loops. And so the agent can work as autonomously as possible. And then use Conductor. It's a free app. You just download it and it'll detect your existing Claude code or Codex setup, and you can just run it and it works. And you'll notice, specifically when you're using Conductor and you're using work trees, that how difficult or how easy it is to actually clone your repo and get somebody else set up on using it. So another quick question that I think people are going to be wondering is that, like, we're writing more code. Is it worse code? Is it better code? And we're also producing it a lot faster, right? Well, is that going to be degrading our services? And I answered this question already a little bit earlier. Our velocity went up, and our change failure rate went down, and our lead times also shrank, right? That's because we didn't just add agents to our workflow. We tightened the feedback loops, and we gave our agents a way to verify their own work. And then we parallelized, right? We made the initial workflow as automated as possible, but as high quality as possible, right? We didn't just focus on making things automated for the sake of automating them. We made sure that we kept those review stages intact. We added those guardrails, and we made sure that the quality was consistent for that single workflow. And then you parallelize it. And so you'll notice that even when you start parallelizing, your quality will degrade a little bit, and you'll have to recorrect and figure out how you can then improve that workflow even more so to keep that quality in check. And so all I do all day is talk to robots. I'm not sure when this happened, but yeah, hopefully that was useful for everyone. Thank you very much. The QR code is just a set of links.
Off.
What was that?
50% off.
No, it's just a set of links from things that I mentioned in the talk. So if you want to go back and refer to some things, it's just, yeah, on my website. Yeah. Oh, do we do questions?
Question time, yeah.
Yeah.
First of all, thank you very much for the talk. That was very intriguing. Two questions. First of all, since you haven't written code in 6 months, aren't you afraid that your capability will degrade if you're going to a different job where you actually need to write code? And the second question is, what's the cost? I mean, you obviously get a salary, but all these agents cost money. Probably not yours, but for the company.
Absolutely. So 2 questions. First one is, if I've stopped writing code, how do I keep that in practice, and what happens when I need to move to a job that actually needs me to write code? And the second one is, what's the costs associated, right? So the first one is a very loaded question, actually, because it's a question about the way the industry is moving, right? If we as an industry are recognizing that the productivity benefits, again, possibly are incredibly outweighing the costs of using coding agents, then the chance of me moving to a job and not being allowed to use coding agents is probably going to be pretty slim. And if that's not the case, and if things do go crashing and burning and I've got to go back to writing artisanal code, then then it's no different to going back and relearning something that I need to relearn. But it's a good call out, because the skill of writing code is different to the skill of reviewing code. And that's a really important call out to make. So as you spend time doing this and reviewing a bunch of code, know that when you go and try and write code, you will be a lot worse at it than you were when you were writing it regularly. So it's a really good point. And my answer to you is, I have no clue, but I think I trust myself to figure it out enough to deal with it. And then the second question was about costs. Yes, it costs a lot, but again, if we're able to demonstrate so clearly that we are shipping and delivering 5, 6, 7 times as fast as we were, then even if it costs us 1 or 2 engineers a year, or anything in that ballpark, it's already going to be making up its worth. But yeah.
Can you hear me? Okay, cool. That's a great talk. Thank you very much. Hopefully AI will not replace us in 2 years. But what I wanted to ask you is that I'm trying all these workflows right now, yeah? And I think for simple tasks, when you have let's say, backend test written, and you have a bunch of small bugs that you want to fix in the service, you can easily parallelize that. And in this case, you don't even need to run the UI, right? You just write the test suite. So that works well. But I find it really hard to parallelize this work when you are building a new feature that changes something fundamentally, and you think about abstractions and how it's going to integrate into the system. Or like you're reviewing the plan, right? And you need to thoroughly think through all of the trade-offs and stuff like that. And it's just really hard to parallelize this kind of stuff for me. And also you need to review every line of code that's produced anyway, right? So what's your experience with that? Do you say, oh yeah, the same problem, or do you still parallelize it? Because I'm always like asking, hey, Opus, please make sure that this code makes sense and like doesn't violate any patterns and looks the same across the board, etc. But still, some input is required, and this is where parallelization can break.
Yes, absolutely. So the context switching is definitely a problem. And when you're working on a complex feature or you're working on a task that is quite involved, your parallelization factor is naturally going to decrease, and you might not be able to do as many things at once. So it really depends on, again, it's building that muscle. So if you're working on a really involved feature or an involved task, you might want to pick up some small backlog bugs that have been sitting there for like ages collecting dust. That's one way that I've found to kind of tackle this problem, is that like if I'm working on one involved task, that I'm working on like one or two like small UI changes or something like completely like negligible, that's just a time, like, oh, I just haven't had time to get around to this. But if you're working on something involved, then yeah, like I don't end up parallelizing as much as I would. I think what's interesting is that the stage that you're at in your company and in your team, wherever it may be, impacts this the most. If you're at an early stage startup, the parallelization factor might be actually quite high because you have to build out a bunch of different things all at the same time. It's not that complicated, or or have a clear idea of what you want to do. Or if you're at a really big company and everything is incredibly well defined and structured. So it really depends on the stage of your team, your company, and the product. But it will vary quite a bit. So yeah, I do face the same problem.
Cool. Yeah, we'll do the last question, then we'll move on to the next one.
So, quick question. Because you've got so many pull requests and so much parallelization with Git work trees, how often do you run into merge conflicts?
So, surprisingly, for the work that I'm working on, not as often, because I pick and choose things that are probably not going to conflict with each other, right? So if I can see that two tickets or two tasks are probably going to be touching the same code base, I won't parallelize them. Because yeah, having to deal with a bunch of the merge conflicts, even if you're using something like Graphite or you have stacked PRs, it's still a pain. So I just avoid it and come back to it when I am done with that part of the code base. For others in the team and in the company, dealing with merge conflicts does end up slowing down this, and that's something that we're looking into and trying to figure out how to improve that part of the workflow. And I've seen a bunch of different things where people are creating agents that are specifically focused on just cleaning up merge conflicts as PRs come up, and then fixing those things up as like in the background. So this is very much open to, it's an open problem and an open pain point for us. So yeah.
Round of applause for Sahil. First ever talk. It's mental.